Aerospace engineering is the field of engineering concerned with the design, development, testing, and production of aircraft, spacecraft, and related systems and equipment. And that's just a general description of the aerospace engineering discipline. There are other factors that go into deciding whether this field is the desired path of study. Myself and Mr. Puckett will go over the schools where one can major in aerospace engineering, the subdisciplines in this field, career opportunities once one graduates, and some miscellaneous information regarding aerospace engineering. Now, some of the schools that offer majors in aerospace engineering are Virginia Tech, UVA, and University of Maryland. Of course, there are other colleges across the US where you can major in aerospace engineering, such as Penn State, MIT, and other big name colleges. These are just ones that are local to Virginia that you can transfer to after Germana. For myself, I plan to transfer to Virginia Tech and study mechanical engineering, but for that school in particular, they all go to general engineering before they move into each engineering discipline, such as mechanical, aerospace, chemical, things of that nature. Now, once one decides on a college to study aerospace engineering at, they also have to pursue subdisciplines in the field before they can have a full grasp of the subject. And some of these subdisciplines are listed below, and I'll go through each one separate. Aerodynamics addresses the flow of air and the associated forces, moments, pressures, and temperature changes. So without aerodynamics, aerospace engineers wouldn't fully understand how the air around the machine they're building influences the behavior and performance of the machine. Flight dynamics and control addresses the motion of the vehicles, including the trajectories, the rotational dynamics, the sensors, and the control laws required for successful accomplishment of the missions. And after all, aerospace engineers always have two objectives: to bring the plane off the ground and to bring it back down safely. Now, the propulsion addresses the engines which have been devised to convert chemical and sometimes other forms of energy into useful work to produce the thrust needed to propel aerospace vehicles. Now, without propulsion for aerospace engineers, the machine they're building wouldn't get off the ground, and they wouldn't be aerospace engineers, they'd just be regular engineers. Now, the materials and structures, I'll go over each separate. So the structures addresses material properties, stresses, strains, deflection, and vibration, along with the manufacturing processes as required to produce the very lightweight and rugged elements needed in aerospace vehicles. Materials are very important to aerospace engineers, since if the materials are too heavy, the vehicles the engineers are making wouldn't get off the ground. Systems design addresses the process of synthesizing vehicles and systems to meet defined missions and more general needs. It's a process that draws on information from the other subdisciplines while also being its own unique subdiscipline. So with that background of the subdisciplines and schools where you can major in aerospace engineering, I'll turn it over to Mr. Puckett to go over career opportunities within the field of aerospace engineering.
Hello, everyone. I'm Jacob Puckett, and I'm going to talk about some of the career opportunities for aerospace engineers. According to the Occupational Outlook Handbook, aerospace engineers had a median pay of $116,500 last year, or about $56.01 per hour. While the pay is well above average, jobs in aerospace engineering are only projected to grow about 2% in the next 10 years, so it may be a more difficult field to find a job in. The largest employers of aerospace engineers are Boeing, Airbus, and Lockheed Martin, all companies who design and build either commercial or military aircraft. As you can see from this map provided by the U.S. Bureau of Labor Statistics, California employs the most aerospace engineers compared to every other state, with 11,450 aerospace engineers working in California in 2017. The state with the next most aerospace engineers employed is Texas, with 7,030. Alabama actually has the third most aerospace engineers employed, with 4,660. Here's an interesting fact about aerospace engineers. They usually specialize in either aeronautical or astronautical engineering. Aeronautical engineers work on aircraft, designing airplanes and testing different construction materials. They may also work on the design of military missiles as well. Astronautical engineers, on the other hand, work with spacecraft, both inside and outside Earth's atmosphere, including both space shuttles as well as satellites. Aerospace engineers may also specialize in some related fields as well, such as thermodynamics, acoustics, or propulsion, depending on what their job entails. Thank you for watching our video on aerospace engineers. We look forward to watching everyone else's videos as well. Stay safe, everyone.